Hello everyone, welcome to the session on Genius Chalk. I am Saurabh and we are going to continue our number system series, and this is going to be part 5 of the number system, where we have been discussing the important previous year questions from the very important topic, that is number system. So if you are new to the channel, please subscribe, like, and share with your friends, and let them get the same benefits as you are getting. So let's start the topic now. All right, so there we have the first question. There is a three-digit number, that is 4A3, and that is added to another three-digit number 984 to give a four-digit number 13B7, which is divisible by 11. Then you have to find the value of A and B. And what we do is, we know this is a three-digit number. So this is 4A3. Okay, what we do now is we'll add here 984, and what we are going to get is 13B7. And you know what the examiner want is that this number has to be divisible by 11. That means what we can do is, this number has to be divisible by 11. Now I'm writing it here, 13B7. Now you know the divisibility rule of 11, right? That is that sum of the odd positions and sum of even positions, their difference must be divisible by 11. So what we are going to do is, we are going to get the difference here. It is 1 plus b minus, this is 1 is the first position, b is the third position, right? So sum of the digits at odd places minus sum of the digits at even places. So you can see it is, second position is 3, fourth position is 7. So 3 plus 7, it is going to be 10. Now 1 plus b minus 10. And what is the rule? The rule is sum of the digits at odd places minus sum of the digits at even places, mod. Mod means if the difference is coming in minus, you take it plus. And this has to be either 0 or multiple of 11. So in this case, we have to make this difference equal to 0 or 11 or 22, because these are the multiples. 11k means multiples of 11, right? 11, 22, 33, 44, and so on. So what we do is, we have this now, 1 plus b. This has to be, you know, this is 10 already. So what I do here, so that I can get 10. So obviously I'll get 9 here, because the first priority is to make 0. If this is 0, this is already 10. If I give b 9, so that means it is 10 minus 10, and that is going to be 0. That means the value of b must be 9. And can I get some other value? No. Why? Because here, please note, this b is a single digit number. It is not a double digit number, right? That means I cannot have value here more than 9. I can only have values from 0 to 9. All right. So if this b has to be 9, and you know these are to be added up, so this is 8. So what this should be? It should be 1, because you know 1 plus 8 is going to give you 9. That means the value of a is 1 and the value of b is 9. Now what is asked? It is asking you a plus b. That means our answer is a plus b. A plus b means a can be 1 only and b can be 9 as per the situation. Can I make 11 difference? No, because I cannot give this b value more than 9. That means it must be less than 10. So I cannot make 11, I cannot make 22, and also I cannot make 33 also, and so on. I can only make 0, and that I've already made with a difference taking as 10. So what is the answer? A plus b has to be 10. So guys, this is the answer for this question. All right, let's move to the next. Now on dividing this number by 357, you are going to get 39 as the remainder. And now on dividing the same number by 17, what will be the remainder? So what is the concept? The same. Suppose this is a number, all right, and you are dividing it by 357. And what is happening? You are getting a remainder 39. All right. Now the same number has to be divided by 17, and you have to tell what is the remainder. Right. Now, what we are going to do is that if you divide this number, so suppose if you divide this number by 357, this means there must be some quotient. So you know the form of the dividend. So this number is called dividend. Dividend. This number is called a divisor, right? And this is called quotient. And as per the basic rule, I know that if I want to write n, that is dividend, dividend is divisor into quotient plus remainder. That means my divisor is or divisor is 357, and this is q, remainder is 39. Now this is my number. I hope up to here everything is clear. This is my number, that is 357q plus 39. Now this number has to be divided by 17. That means what I want is that this 357q plus 39, this has to be divisible by 17, and then I need to find the remainder. Now guys, if you focus properly, you will observe if this number is divisible by 17, that means first this part has to be divisible by 17, then only I can check about this part. So the first and the foremost condition for this question is that whenever you get this kind of question, always check whether the first divisor is the multiple of the second divisor. So that means this must be cancelable, and this must leave zero remainder. So let's check 357 by 17. 17 ones are 17, and then sorry, 34, and this has to be 34, and this is 17. So 17 ones are 17, of course, 0. That means remainder is 0 here. Now I can go ahead with the question. So 17 and this 39 divided 17 to the 34, and the answer is 5. Remainder is 5. So guys, this is the trick also of this question. So this is the whole overall concept. Now what is the trick? The trick is whenever you have two divisors, check those two divisors first, whether they are divisible by each other or not, right? Like 357 must be a factor of must be a multiple of 17. If this is a multiple of 17, that means then only we can go and check whether what remainder 17 is giving after what remainder 39 is giving after dividing it by 17. So the answer is 5, right? So what is the answer? 5. So in exam, what you do, and if remember, suppose it is not 357, it is 358, then obviously 358 is not divisible by 17. So there is no need to go ahead. The answer of the question is cannot be determined. Cannot be determined. Why so? Because if this number is not divisible by 17, we cannot say anything about this, right? We can only say when this number is divisible by 17. So first you will check that 357 is divisible by 17. If it is, then fine, go ahead. This is divisible by 17, then go ahead and check the remainder, whether what is the remainder when 39 is divided by 17, and that is going to be 5. So that is my answer, right? Okay, let's move to the next. Next is if the product, this is a number, and we need to find the product of it. This is 4864 into 9p2, and this number has to be divisible by 12. You know the divisibility rule of 12? Yeah, it is 3 into 4. It is 3 into 4. That means first I need to check it by 3, and then I need to check it by 4. So if you observe, what is the divisibility rule of 4? It is the last two digits. If the last two digits are divisible by 4, then the complete number is always divisible by 4. That means I need to check the last two digits here. So because I am treating it like this number is multiple or multiple of 4, and this number is multiple of 3. Now go ahead. So 64 are the last two digits of this number, and 64 is completely divisible by 4. That means this complete number is also divisible by 4. So that means, because 4 is done, now I'm left with 3 to check it whether this number is divisible by 3 or not, and what condition it can be divisible by 3. So let's check. So this has to be like, if this is 9p2, and what is the rule for 3? I guess you know this. Sum of digits of any number, if those are divisible by 3, the complete number is divisible by 3. So just find the sum. 9 plus p plus 2, and that is 11. 11 plus p, tell me what value I can give so that it is divisible by 11 3, sorry. So 11 plus 1, and that is going to be 12. That is the nearest number, and you can see this p is also available in the option number 4. That means if this is 12, now the sum of digits is 3. 1 plus 2, that means this number is now divisible by 3. This was already divisible by 4. That means our question is done. The answer is first option. I hope this is clear, right? Next. Now, which of the following is the one of the factors of this part? Okay, let's find the factors. So the rule is whenever you see power, and some number to the power, what you do is remember this rule: x to the power n plus a to the power n is always divisible by x plus a when n is odd. Let me give you this example. Suppose this is if you put n equal to 1 here, this must be x to the power 1 plus a to the power 1 and divisible by x plus a. And you know that these are the same denominator and the numerator is same. So this is 1. If you put n equal to 2 also, the same thing you will get. If you put, so if n is odd, if you get n equal to 2, then now there is a condition: n is odd. If you put n equal to 2, then you can't say, actually. You can't say, because this cannot be written in this form in any way. So it is not valid for n equal to 2. But if you put n equal to 3, it has to be x cube plus a cube divided by x plus a. That means this number, and there is a formula for a cube plus b cube. And what is that? I guess you remember it. That is a plus b, that is x plus a, then a square minus ab, that is ax plus a square. This is the formula. Now you can see that this x plus a and x plus a are cancelable. So what? This is completely divisible by x plus a also. That means for n equal to 1, n equal to 3, and so on, if you put n equal to 5, this formula is always valid. So remember this rule. Now check the conditions here. What is given? Here also we have n odd. You can see the powers. Powers are 47 and 43. That means n is odd. That means they must be divisible by what? So let's check. They must be divisible by, see, this is 47 to the power 43, right? 43 to the power 43, right? Or 47 to the power 47 and 43 to the power 47. First thing, observe, n is same. You observe here, this is your n and n is same. Here also n is same. So as per the rule, this must be divisible by 47 plus 43, because this is x, this is a. Compare here, this is x, this is a. Similarly, this is x, now 47 is x and this is a. So that means this is divisible by 47 plus 43, which is given in the second option, right? So this is the answer. All right, let's go ahead. Now we have the question of successive remainders. Now read it very carefully. On dividing a number by 585, a student employed a method of short division. He divided the number successively. This is a very important point: successively, by 5, 9, and 13, and which are of course the factors of 585, because you know that any number is only divisible by its factors. So these are the factors, and got the remainders this. Now if you have divided the number by 585, the remainder would have been what? All right, let's try to develop the strategy to solve this kind of question. So what we do is, there is a method like, you start with, if you're dividing a number by 5. Okay, you are dividing a number by 5, then you are leaving with what remainder? It is 4. Okay, then if you are dividing a number by 9, so then you are dividing, getting a remainder 8. Okay, I'm writing one below actually. Then if you are dividing the same number by 13, then what is the remainder, guys? It is 12. So these are the remainders I have written. And the basic rule is, this is divisor, this is remainder, and dividend is divisor into quotient plus remainder. Now here, suppose you take any divisor. If you take 13, now 13 already. The quotient is not known, remainder is 12, right? This is the remainder, right, when you divide this number by 13. The problem is with question. So what I'll do is, I'll take the smallest value. So just to simplify the question, so what is the remainder? What is the question I'll take? That is 1. Okay, so if the question is 1, that means I can write here 1, right? So that means 13 into 1 plus 12, that is 25. 25, right? Now this I'll write here. That means now, so what is the process? See, the process is this. I'm writing 1 here, and this is divisor into quotient plus remainder. Now what I'll get is, I'll write here in the next step. This is actually little up, so you can write it 25 here. You can write it right here, 25. Now for the next divisor, for the next dividend, sorry, we have the next divisor 9, and I need to multiply this by the, now I've got the quotient, right? So 9 into 25 plus this remainder. I hope you're getting my point. So this is 225 plus 8, and that is going to be 233. All right, now 233. Now go ahead. I've got the quotient here also. Now the next divisor and the next remainder, I need to add it. So next is 233 into 5 plus 4. And what is, we're getting 230 into 5. It is 1150, and 3 into 5, 15. So that is 1165 plus 4, and that is going to be 1169. So this is what I am getting as the dividend on the top, right? Now what you need to do is, you just need to observe that you need to divide this 1169 by 585. All right, 585. So divide it and get the answer. So I'm rubbing it all. 1169 need to be divided by 585, and if you double it, this is somewhere more, I guess. 2 5s are 10, and this is 580. So this is 17. This is 1170. This is one more. So this is 585 subtracted, and there you get the answer as 584. So this is the way we treat the questions of successive remainders, right? So very important question for exam, already repeated many a times, so do it very carefully. All right, next. In a division sum, the divisor is 10 times the quotient and 5 times the remainder. So you know the rule, right? We know the rule. The rule is that dividend has to be divisor into quotient plus remainder. Now the remainder is already given, that is 46. So I'll put it here. And it is also given that this divisor is, this divisor is, this divisor is 10 times the quotient. So can I write 10 into q here, and then plus q, right? So this is 10q, oh sorry, into q, right? This is the same sign. I'll copy here. Okay, so can I find the divisor? Yes, you can. Divisor is 10 times the quotient. Now the point is, we don't know the question, and something is given. Divisor is the same. Divisor is also given as 10 times the quotient. Divisor is 10 times the quotient, and also 5 times the remainder. You can see 5 times the remainder. So just focus. 5 times the remainder means I can write 46 remainder is 46. So what is the 5 time of it? So 40 into 5 is 200 and 6 into 5 is 30. That is 230. That means, guys, my divisor is 530. Sorry, 230. It is 230. Now, if the divisor is 230, if I place here, can I get the question? Yes. So this is 10, 10 multiply, divided, cancelled. The Q has to be 23. That means I've got my point that the question of the question is 23 and divisor is 230 and the remainder is already given. So can you find the equation now? Yes, we can. So what is the divisor? Divisor is 230, right? What is the quotient? Quotient is 23. And what is the remainder? 46. So 23, 23. You know the square, it is 529. 1 0 I'll put because of this 0. And then 46. So what is my answer? 6, 3, 3, 5. And that is the number. This is the dividend we were looking for, right? All right, next. What smallest number should be added to this so that the sum is completely divisible by 6, right? Divisible by 6. So let's find. There you have a number 4456. And what should you add so that this is divisible by 6? Let's find first what we need to add by dividing directly. So this is 6 7s are 42. This is 2 5. 6 4s are 24. This is 1 6. 6 2s are 12. This is 4. So I'm getting a remainder 4. Okay. And in order to get a perfect multiple, suppose you divide 6 by 5, right? And then you are getting one remainder. What you do to get the multiple of 5? You will subtract this 1 from 6 and it is 5, and 5 is obviously divisible by 5, right? That means uh, this is the same concept. So I'll subtract this remainder here and I'll get 4456 minus 4, and that is 4452, right? So this I have subtracted. This is a proper multiple of 6. This is a proper multiple of 6. But read the question. It is given that what should be added to, not subtracted to. Here I have subtracted. So I have subtracted 4 and I have got this. And this is a proper multiple of 6. So in order to get the next multiple of 6, I need to add only, na? Because here I'm subtracting. And the question is about adding up. So what I need, see, if I ask you that after 12, what is the next multiple of 3? So what you do is you add 3, na? If I ask after 15, what is the next multiple of 3? That is 15 plus 3, that is 18, right? That means I need to add the same number of which I'm finding the multiple of. So this number is perfectly divisible by 6. So in order to get the next multiple of 6, I need to add 6 again because I'm dividing it by 6. So 4458 is my number. Now you can relate what we have done. We need to add in 4456. So what we have added in here, we have added 2 here, and that is the answer of the question, right? So this is a proper multiple of 6 again, but we have to tell ki as per the condition of 4456 what we have added. So we have just taken out the difference. So this is one method, right? Another method is, after you have divided, what you do is just take the difference of the divisor and the remainder. This is also viable. If you take the difference of 6 and 4, and that is 2, if you add this 2 here, you are getting the same answer, that is 4458. So this is also applicable. If you want to learn this way, you can remember this number plus divisor minus remainder will always give you the answer of the question. All right, next. What least number, similar type, what least number must be subtracted from this so that it is divisible by, so the remainder is divisible by 87. So let's find and divide it by 87 and find the answer. So we're going to get 87, and then we have 13601. So let's solve it. 87 ones are 87, and 16 7. This gives you 9, right? Then 12 8 4 4. This 0 is here. Now get what you'll get. 9 4s are 36. If you try to get near to 4, so 28, 34. You can go ahead. 5, 35, 80 into 5, 400. And 7 into 5 to 435, which is fine. Next, 87 into 6, if you go, 87 into 6, 80 into 6, 480, and 7 into 6, 42. So you just add. Now you are getting above 490. So this is not viable. So I'll not take this. So we can take into 5. Let's take it into 5. And that is take it into 5. That gives you 435. So this is 435. Now subtract again, and you are getting 5, and here you're getting 5 again, and 551. Now subtract again. Now which divisor you need? So check it. 87 into 6 we have just checked, so that was 522, I guess. Yes. And 87 into 7, you 80 into 7, 560, and plus 49, little ahead, 600. So we will not take this. So this is 522. So this is into 6, and we are getting 522. And this is 9, and this is 2. So 29 is left, right? Now you have seen key what least number must be subtracted from this, so that the remainder, whatever is left, see, it's not that remainder, whatever is left is talking about is divisible by 87. That means, guys, in order to get a perfect multiple of 87, I need to subtract what? 29 only. So if you subtract 29, you see, you can check also. This is 2, and 11, 9, 2. That is 9 to 7. This is 5, 1, 3, 5, 7, 2. If you check it, this will be proper multiple of 87. So what is my answer? Answer is 29. You can check it, right? This is obviously the same concept. If you are having some remainder, if you subtract that remainder, that will always be divisible by the given number, right? That is the answer. Let's move ahead. Now this is another example of divisibility rules, where we need to check. This is a number 476 star star 0, and this is divisible by both 3 and 11. So okay, 3 and 11, this is the, and you have to tell the non-zero digits in the hundreds and the tens places respectively. Okay, so you need to check this and this, what are the values they can take. So as per the rule of 3, what we need this number has to be completely divisible by 3 only and only if the sum of the digits, we know for 3 we have to find the sum of the digits. So just find 4 plus 7 plus 6 and plus 0. So this is 11 plus 6, this is 18. So this is already divisible by 3. So I need to add two numbers here, two stars here, two stars here, and the point is the sum of the two must be also divisible by 3, because 18 is already divisible by 3, right? So which values you can take? Can you take 7 and 4? If you take 7 and 4, the problem is the sum of the both is 11. So this is not divisible. So this answer is cancelled. This option is cancelled. If you take the second option, 7 and 5, yes, 7 and 5 is fine, where the sum of the digits is 12. But we need to check it for 11 as well, remember. So check for 11 also. Now I'm writing the number for 11. What is the rule for 11, students? Sum of the digits at odd places minus sum of the digits at even places, that has to be perfectly divisible by 11, or the difference must be 0. So if you take the digits, this is first position, third position. So now I'm rubbing it. This part, I hope this is clear. So already divisible by 3 with 7 and 5. So we are checking with 11 now. So 1, 3, 5. So if you sum it, it is 4 plus 6. First position, third position, fifth position, and star, minus the second position. This is the second position. This is the second position. This is the fourth position, and this is the sixth position. So this has to be like 7, this one, then this star, this one, and this one plus 0. All right, let's check. Now already we have given the values 7 and 5 to this. So this is what? This is 10. 10 plus something, subtract 7 plus something. And here we can check for 0, the minimum value is 0 for the difference. So already you have given 7 and 5. So let's check. If you give 7 here, suppose, so this has to be 17, 10 plus 7. And if you give 5 here, this has to be 12. So this is not divisible by. Or if you do vice versa, you give 5 here, this has to be 15, 10 plus 5. And if you give 7 here, 7 plus 7 is 14. In both cases, the difference is not coming out to be 0. And obviously will not give value more than except this 7 and 5, as we are taking the option. So this is not properly uh, divisible by this. So we'll cancel this option as well. Now go for the next option is 8 and 5. So let's check. So if you take 8 and 5, now write it completely. Let's see. So if you give 8 and 5, right? So this is see, 4, 7, 6. Suppose you give 8, you give 5, you give 0. Now find the sum. 4 plus 7, 11. 11, 11 plus 6, 17. 17 plus 8. Uh, this is 25. 25 plus 5, 30. Yes, this is divisible by 3. Or you can check this way also. See, 4, 7, 6, 8, 5. Just cancel all the multiples of 6. 6 is already a multiple, cancel it. 8 and 4, 12. 7 and 5 also 12. These are all cancelled. So that means this number is divisible by 3. Now check for 11. All right. Check for 11 now. So we have given this already. The 4, 7, 6. Now there are two options. I can give 8 here, right? And say 5 here. Or the second is I can give 4, 7, 6. And then I can give 8 here and 5 here. All right. And then the rest is same. So, okay, now check. 4 plus 6 plus 5, how much? 15. Okay, minus 7 plus, sorry, 8. The even place is 7 plus 8 plus 0. And you can see this is also 15. Yes, this is also cancelable by 11. So my answer of the question is third option, as this is cancelled by both 3 and 11, right? Next, if the number is divisible by 11, then the smallest whole number in place of star. Again, the same principle will apply and get the answer. So try. See, I'm expecting that you're trying the question before I'm solving it at least once, so that you understand the question better. So here we have again the same rule. No? The rule is sum of the places at odd and the sum of the digits at even places. So these are the odd places in red. So find their sum. 9 plus 2 plus 5 plus 6 minus the sum of the digits at odd places. So 1, 7, star. All right. And you have to keep the smallest whole number, remember. Okay. So 7 plus 1 plus star. All right. What is the sum? 11 plus 5, 16 plus 6, 22. You know the difference has to be 0 or a multiple of 11. So first we need to check it for 0. This is 8 plus star. Now tell me, can we get 0 here? Can we get 0 here? Tell me. See, this is 22. In order to get this thing as 22, you need to give it 16. 14, which is not possible. Why? Because this this star is a single digit number, right? It's not a double digit, so we cannot have 0. Okay, we'll cancel this then what we may have next is 11. Let's make 11 then. It is 22, and how can I get 11 here if the sum of these two is 11? So for that, this hash has to be what? 8 plus 3, then only it is 11, right? So the hash, the star value is 3. 22 minus 11, and this is 11. Now it is asking you some others also, but so if after 3, what you'll get? If you have 22 here, then it is 22 minus 22 also. Again the same problem. If you give 14 here, it is not possible because again star is a single digit value. So what is the answer of the question? We can only give smallest digit as 3, right? So guys, that was a session. I hope you enjoyed it. So thank you very much, and you can like, share, and subscribe our channel to your friends and to them who are studying for CUET and CLAT placements, banking exams, SSC exams, every exams of India where competition is there for aptitude and reasoning. So thank you so much. Hope you meet soon again. Thank you.